Hello, Miss Barron here. In this video, I'm going to be going over the Around the Room pH stations. I'm just using the e-learning version for this, just in case you, struggled with this activity or you kind of want to see all these types of questions again. So I'm going to start with station 1. So it's asking me, what is the H+, so that's the hydrogen ion concentration, if you have a 1.7 times 10 to the negative fourth molar solution of H2SO4. So this is one of those problems where we're actually not going to use any of these equations here, okay, because I don't see like pH or POH or anything. But what you need to do is you're going to have to do dissociation. So notice that you have H2SO4, which is an acid, and they're telling me that this is the concentration of this, okay? However, when you put H2SO4 in, when you use it to make a solution, it's going to dissolve and what we call dissociate. So when it dissociates, okay, you're going to get 2 of those hydrogen ions, okay? Now remember that this number right here, that 2, that represents number of moles. And this is a little bit as to why we do this. So if you have a 1.7 times 10 to the negative fourth molar solution, so that's the same thing as saying moles per liter, okay, of that H2SO4, you have to take into account that this is also moles here. So that's why you're actually going to multiply by 2, okay? That's where it is coming from. Okay, so it's a little bit as to why. So what we're going to do, how I would normally show this, is I would take that molarity and I would multiply it by 2. So in my calculator, I'm going to do 1.7, and again, please don't do the times 10 whatever when you're entering this into your calculator. Using the E function is a lot easier. You hit the second blue button in the upper left here, and then you're gonna hit, you see the 2 blue E's, it's that button above the 7 with the comma. That's how you get the E, and then make sure you do -4, not -4. Okay, and that's how you enter it into your calculator, and we're going to multiply that by 2. So we're going to get 3.4 times 10 to the negative fourth, and that is our, it's molarity, but this is also what we were looking for, which is the H+ concentration, which technically that's the same thing as molarity because we're talking about big M, which is moles over liters, which is concentration. This also represents concentration. And again, you were trying to find the H+ concentration, so that's why you had to take this into account. And since this was an acid that you had to dissociate, you were already finding the H+ concentration. If I asked you to find the OH- concentration, well, you would have just had to have taken this answer and plugged it into this equation here in order to find the OH- concentration, if you had to do that step. Okay. All right, so that's a little bit of review for that question. Let's go on to station 2. I'm just going in the stations in order. What is the OH- concentration of a solution if it has a pH of 3.4? So this is when we're going to start using those equations. So one of my go-tos if I have pH or POH is to use this equation right here. As long as you have pH or POH, you can find the other. So we have 3.4 plus POH equals 14. So we're going to subtract 3.4 from either side. Okay, so we're going to do 14 minus 3.4. We're We're going to get 10.6. Now, the reason I have to do this is because if you look here at our equations, they gave me pH. Technically, you could have also used this equation to start with as well to find the H plus concentration. And then you could have used this equation to find the OH minus concentration. However, what I'm deciding to do is I found the POH concentration, and now that the POH, excuse me, and now that I have that, I can plug it into this formula to find the OH minus concentration. So I'm using this equation and then this equation, but you could have also used this equation and then this equation as well, and you would still get the same answer. I just think this way is a little bit easier because it's less things you have to plug into your calculator. So the OH minus concentration, which is what we're solving for, is 10 to the negative POH, which we got to be 10.6. So this is when you're using the little caret thing on your calculator. So I'm going to do 10, the little caret thing, it's above the division sign right here. And then negative, make sure you do negative, not minus, 10.6. So we're going to get 2.51 times 10 to the negative 11th, and that is our OH minus concentration. So that was an example of a multi-step problem. Okay, moving on to the next station. What is the pOH of a solution of HClO3 that has a pH of 2.5? So this is really easy. We're just going to use, again, this is kind of one of my personal go-to equations. We're just going to use that equation because they gave us pH, which is 2.5, plus pOH, which is what you're solving for, equals 14. So we're just going to subtract 2.5 from either side. Okay, let me get the right thing here. So we're going to do 14 minus 2.5, and we're going to get 11.5. And that's our answer. So kind of like what I did here, right? I found the pOH. This station just required me to do an extra step to find the OH minus concentration, or the hydroxide ion concentration. Okay, next we have what is the H plus concentration of a solution of HCl if the pH is 4.1. So this one's also really easy as well because it doesn't require multiple steps. If you look at your equations here, they gave me the pH and I'm looking for H plus, so I can easily just use this equation. It's not going to require multiple steps. So we're going to do H plus equals 10 to the negative 4.1. That'll give us our H plus concentration, which is what we're trying to solve for. So I'm going to do 10, and I'm going to use that little caret. Again, it's right here. It's under the clear button above the division key. And then we do negative. Make sure you do negative and not minus. 4.1, so I'm going to get 7.94 times 10 to the negative 5th. That's going to be my H plus concentration. Okay. So that was easy. That was a one-stepper. Let's go to station 5. Okay, so kind of similar to station 1. So it's asking about the OH minus concentration of, so this makes sense. They're asking for OH minus and they're giving you a base. This is calcium hydroxide. Very similar here when they were asking for the H plus concentration and they gave you an acid, H2SO4. So again, I don't see pH or pOH in this problem, so I'm actually not going to use any of those equations. So all I'm going to do is I'm going to disassociate this. I'm going to break it up into its individual components. So you have the calcium, and then you have the OH minus, which is the hydroxide ion, and note that you have 2 of them. Okay. And again, that 2 is representing number of moles. And this concentration right here is moles per liters. So we're going to have to take that 8.1 times 10 to the negative 6, and we're going to have to multiply it by 2. So in my calculator, I'm going to do 8.1. This is when I use that E function. So I'm going to do that second blue button, and then the button above the 7, that comma, E negative 6 times 2. And I'm going to get 1.62 E negative 5. I just write it as times 10 to the negative 5th. If you wrote it as 1.62 E negative 5, that's also, and both of these would be acceptable answers. I'm just very much used to writing it in this format here. Okay, what is the pH of a HClO4 solution that has a H plus concentration of 3.0 times 10 to the negative 4th? So we're trying to find we're trying to find pH, and they gave me the H plus concentration. So I am going to have to use these formulas. So if you look up here, pH is equal to negative log of the H plus concentration. So we only have to use that formula. So the pH is equal to the negative log of this concentration, 3.0 times 10 to the negative 4th, because that's our H plus. So in my calculator, you're going to do negative. So make sure you do the negative and not the minus symbol. The log button is to the left of the 7. And then we're going to do 3.0, and then we have to do E, and then negative 4, and then I just close the parentheses. Enter, we're going to get 3.52, and that would be my pH. Generally speaking, when it comes to pH and pOH, they should be numbers like this, because pH plus pOH should give you 14. So those numbers should be under 14. And then when we're talking about concentration, oftentimes they will be in this format. They're very small numbers. Okay, station 7, it says this is going to be a multi-step one. So it says, what is the pOH of a solution of HNO3 with a H plus concentration of 3.9 times 10 to the negative 7th? So there are actually a couple different ways that you can approach this problem. So the thing is they gave us H plus. Well, I can't use H plus to find pOH, but I can use it to find pH, and if I have pH, then I can find pOH. So we can actually do what we did in the last problem, but we're just going to take it one step further. You could also use this equation here to find the OH minus, and then you could plug in the OH minus concentration to find the pOH. So there's actually two correct ways to solve this. I tend to avoid this one usually just because it requires a lot of extra typing into my calculator. But it's not wrong to use that equation because there are multiple correct ways to solve for this. So what I can do is I can find the pH, which is what I did in the last problem, and that's the negative log of this concentration. So I'm going to go ahead and find that. So I'm going to do negative log, okay, negative button, the log button, and then I'm going to do 3.9. The second button, E, negative 7. So I'm going to get I'm going to do 4.1. So that's the pH. And now that you have your pH, you can find your pOH by using that other equation. So our pOH, so then I'm going to do 14 minus that, 7.59. How I did that in my calculator is it's really easy to do. 3.9 E negative 7, let me do that. Okay, so if you just don't want to, if you want to avoid typing, you can use the ANS button, which is